All right, welcome to part 3. But in this one, we are actually looking at what's inside of that GUIs folder. There's a GUI example folder. And again, this is structured where you have this is similar to how you'll see applications done, where there's a folder that essentially contains all the pieces. And that could then also be turned, you could turn that into a jar like you've seen when working with the Finch. But yeah, it's better to sort of have a folder which contains all the pieces of your application. You can have subfolders and that sort of stuff within there, but basically we're structuring that. And that's an ad hoc package because, as you'll note when we look at the code, I haven't specifically defined a package. I could have, I just didn't. I used basically an ad hoc package by dropping everything into the same folder. So we seed it into the folder, and when you run an ls, what you should see is the fact that we've got a main.java, we have a GUI example.java, a button action.java, and we have 2 images. Okay? And we're getting fancy with this one. But as you might guess, main.java contains the main method. Okay? It's sort of what kicks things off. And often, like I said before spring break, is that in your more complex programs, your main method really is just there, and you'll have a specific Java program that is the main one, and that basically is just the ignition. It starts everything off, and then other things are built, and they build other things, and so on and so forth, and it builds the universe. And the main is just sort of to, boom, kick things off. Okay. GUI example, that's actually where we actually build the GUI, and then button action is where we actually define what actions occur when buttons are pressed. That's what actually implements the action listener interface. So this is sort of taking cues from both the things you saw in video 1 and video 2. GUI example is much like custom GUI in that it just really builds the GUI. Okay, and then unlike WeMadlib, where WeMadlib not only built the GUI but was the action listener, instead we have action listeners, the class that defines what events or what happens when events are caught by an action listener. That's in its own separate class, and this is a better model for doing modular design. So let's start off by taking a look at GUI example. So we'll say nanospace GUI example.java, and we'll take a gander at this thing. So as you'll see, fairly similar methods to what we did with WeMadlib. Okay? Now, we don't implement action listener because that's not this class's job. Its job is to simply construct the GUI. Okay? Its job is not to handle actions. Again, think of it from sort of a Unix philosophy of here's a little tool and this is its one job, and here's a tool and here's its job, and then you combine them together to solve more complex problems. So we don't need to import the event classes. We just basically build it like the custom GUI. And so we define all of our pieces, our various buttons, our frames, our frame, the panel. And one note, in these examples, we've primarily been just doing one panel on one frame. You can actually, if you want to, you can use grid bag layouts, and I think there's like a mesh layout and that sort of stuff, where what you can actually do is you can have your main panel, define a layout for that, and actually create other panels that go in each of those, and the component, each of those sort of sub panels has its own layout, and you put various components in there. That lets you create sort of really complex, interesting looking GUIs. And you've largely sort of seen this process before where we create our buttons, because this is primarily just a button interface. And as you can see, even without looking at the GUI, you can probably guess this is creating your sort of standard dial pad or number keypad structure. One thing that's a little bit different, as opposed to using an asterisk for the star and the pound sign for the hash, I'm bringing in images. One is of a star and the other is of hash browns, just to show you that, hey, you can construct these in different ways depending on which constructor you call. And again, you can find that information by looking at the Java API. Okay? So always go to the documentation, figure out, hey, what can I do here? Can I do this a different way? As you can see, it doesn't have to be text, and you can actually drop an image in that button when it's generated. And you've technically seen that before. And as you can imagine, if you've seen an interfaces where you can say, hey, I want labels and images, or you just want images, or you just want labels, all that's doing is reaching in there and changing the text or changing what's appearing on that button. And that can be done by just writing an action listener that does that. So All the fancy stuff you see by the GUIs, it's really just tying an action listener to something and then saying, hey, when this occurs, make these changes to the you set various setters and getters to do what needs to be done to each of those components. Fairly straightforward. And then we, of course, have our GUI example constructor. Our GUI example constructor, I was sort of lazy and I really just added an action listener to button 1, but you could essentially copy that same piece of code if you wanted to tie an action listener to all the other buttons. This just means that only pressing button 1 will actually trigger an action, but again, you could expand upon it using the same exact pattern. You just rinse and repeat. Okay? So that takes those, sticks them in the appropriate, just adds them in whatever specific order because I'm using the grid layout. We'll set our default close operation, add components to the panel to the frame, and set it visible. And that's basically all that thing does. This is basically like custom GUI, except for as opposed to the building of the GUI being in the main method, it is in its own constructor, which is better form. One thing to note about the action listener that we added to button 1, okay, if you look back up at the top where we were building all our components, one of the things that we did was we actually built a new object of type button action. Okay, so that wasn't a component that was a class made available to us by importing libraries. That's a class that we made ourselves, which is that button action class. Okay, and we simply say, hey, we want one of those things, and we use it to bring it in here. Again, this is an example. This is essentially like data structure. So you create classes that are their own little individual things, and then you can say in another program that is a larger construction of something, say, hey, I want some of those smaller pieces that are going to be part of my larger whole. Okay, so for instance, you could have a contact list. You could create a contact class that defined what was held in each contact, and then you create a contact list that said this is how you work with all those contacts, and then that contact list could go into a larger application itself. That's the basis of data structures. So but yeah, that's all this code essentially does, is build it. And yeah, so and again, add action listener, that's what we add is not this, because it doesn't look back at the same piece of code. Instead, it looks at that new object of type button action that we built. So we'll go ahead and close out of this, and since we're talking about the button action, we'll go ahead and take a look at that button action.java file. So nanospace button action.java. And this is basically, we import in our various libraries, and button action implements action listener, which means, hey, it's promising to have a action perform method. Okay. And the only thing we do differently, and we may jump back to GUI example to talk about this, is that we could have just, when we created the new button action back in GUI example, we could have said new button action and used empty parentheses to call the default constructor for this class. Okay, but just to show that you can do a little bit different, since we're creating our own button action here, we can actually, since we've bundled it in its own class, you can create overloaded constructors where you actually take in things from whatever class is constructing this action listener. So in GUI example, we called an overloaded constructor and passed in a string, and that string was the word whatever. Okay, so I've written this code so that there's an overloaded constructor. So if the overloaded constructor gets called and a string is passed into it, it takes that string and sets it to my message field or class variable that I've defined at the very beginning of this, before the constructors. Okay. It then has the action perform method. So the default constructor basically builds it with whatever message, or so the default constructor would just build it, but there would be no message. Building it, calling the overloaded constructor, builds it, makes it available with that message set up. Okay, and then what you'll notice that in the action performed, essentially, whenever the action occurs, it prints out or does some specific action based on the code, just like you saw in WeMadlib. In this case, I'm doing something a little different. I'm actually using a J option pane, and you may see this. Or you have seen this in other GUIs where you have sort of your main window, and then you'll press something and a sub window will pop up, or a little pop-up window will occur. So in this case, I'm actually using the J option pane to give myself a quick little pop-up window that will pop up when I press the button, the number 1 button on my main GUI. page, or main GUI. And in this case, it actually just displays the message, which is whatever. Okay. You could build upon this, duplicate it to have each of the buttons do different things. You run the get source, but essentially you can take lessons that you've learned from custom GUI and WeMadlib and apply them to flesh out this. And actually that would be, I would say that would be good practice for you all, is to take this and tweak it, add additional action listeners, write your own overloaded constructors inside a button action, flesh out that action perform method so it does other things. You know, I had it pop up a J option pane. You could technically write another custom GUI, which is sort of a little mini sub window that uses border layout or grid layout or whatever you want to, instead of using the J option pane. Or that sort of sub window could have things that occur, and when buttons are pressed, that brings up J option panes. And you've seen that in most of the GUIs that where it triggers, hey, here's a sub window, here's this window, and so on and so forth. All right, we'll go ahead and exit out of this, and we'll take a look at main.java, which, as I said, is sort of the main program that you run. So Nano it's main.java, and again, little different. One of the things that we have to do is we're going to be doing, you know, so when you saw the GUIs displayed here on the Mac, okay, they sort of inherited the standard frame, which is the red bubble, but some of the components were very sort of swingish looking, and it'll be very apparent if you're on a Windows machine, sort of what the look and feel of the swing components are versus your native components. So what I'm doing here is I've added some code. I've added a try catch block. Okay? And a try catch block is classically how you handle exceptions. And exceptions occur anytime you are reaching out of the program into some other system. Something could go wrong there. Okay? So if you're doing file IO and you reach out, you might not find a file that could generate a file not found exception. Or, I mean, there's also anytime you're reaching outside of that program, okay, that can generate an exception or an error. And to deal with that, those of you that were used to Perl, where you had sort of the die statement, that's essentially, that's very basic exception handling. We're basically saying, hey, there's an error, well then just die, just quit the program, okay? The try catch block is used to say, try to do this thing that reaches outside of this program, interfaces with the underlying system or another whatever. And if it works, move on down the road. Otherwise, catch that error or that exception class, that object, and crack it open and perform something. So you could have written the code where if you catch an error, then instead you know, if you're dealing with files, you could prompt for another name of a file and say, hey, that was an incorrect file, give me another name. All sorts of different ways of doing exception handling. The try catch block is classically your structure for dealing with actions that could cause exceptions or errors. So I imported the up at the top, the library to give me exception functionality. And then essentially all this class has is it has the main method, which triggers things. And as you'll see, the majority of what it does is just generate a brand new GUI example. Okay, and go again, the GUI example just said, hey, this is how you construct the GUI, the button, and the GUI example created button actions, which you can look at the code and say, okay, that's how it defines all those various actions. So again, it's very much a Lego approach to building a program. Okay? The try statement in there, what I'm doing there is I'm reaching outside of the Java program and trying to contact the underlying system, the user interface manager, to basically say, hey, what's the look and feel that you have? What's the color scheme you've chosen? And if possible, can that theme be applied to the swing components? As opposed to using the default theme, the default look and feel of the swing components, reach out, pull the underlying system, be it Windows or Mac or whatever, and see if you can get a theme that it can pull in and apply so that it looks more like a native application as opposed to a Java application that's using the swing components. Okay, so basically, if it can, it sets it. If it doesn't, there's an error, well then it just catches that error and it goes ahead. It still runs the program, but it runs it with the default theme. But we try to incorporate the underlying theme of the system and apply it if we can. If we can't, no worries, we still run the program. Okay? So that's what that try catch block does. And then of course we generate that. And of course, because of the set visible back in GUI example, that's what keeps it persistent on the screen. So go ahead and exit out of this. Okay? And if you run an ls, you'll note we just have a bunch of .java files. The nice thing is, because all of these things tie together, we can run Java C space main.java, hit enter. That will compile main.java. But if we now run an ls, you should see that there are class files for everything else, because main called upon GUI example, and GUI example called upon button action. So it sort of went through, there were no errors, and so it was able to compile each of those. Okay? And again, this modular approach means that you can go in, you can work in groups more easily. You can go in and tweak one set of code and not mess with something else that's already working. Or something's not working, you sort of put it to the side and rely on a different type of code. So you can easily, that allows you to sort of build upon it as it goes through various iterations of the application as a whole. Okay? So it's when you're engaged in software engineering or just application development, you really want to move toward, how do I separate this thing out into, this is this one little chunk of code that does this thing really well, and here's this other chunk of code that does this little thing really well. Okay. That also means that if later on you're like, oh, I came up with a much better idea, you can write that later on and basically swap out the old thing for the old class for the new class. Okay. Think of it as the assembly line applied to programming. Okay. So it's much easier to, when I bust the screen on my phone, hey, I can just it's not, oh, I busted the screen on the phone. Well, the phone's completely unuseful. No, I can swap out the screen. Okay, and still have a functional whatever. Okay, or I could upgrade. Well, you don't really do that with phones, but you've upgraded other things before, and there are certain things that you can, like, so on actual full-fledged computers. Although I guess the phone is a full-fledged computer, but you can upgrade desktops and that sort of stuff much more easily than you can a phone. But that's the basic idea. This is modular design. This is object-oriented programming, and it's just good software engineering practices to focus on before you write any code, to say, okay, how do I break this apart into its pieces so I can isolate it and say, boom, work on that, work on that, work on that, work on that. Okay, and you can't see me right now, but I actually have, those of you that, yes, since you've seen me in class before, I'm actually using my hands because that's me. So imagine I'm putting things out in space all around you. But yeah, so it built all those. So let's go ahead and run it. So we'll go Java space main and magically delicious. So we can press, let's press on the number 2. And nothing happens. We can press on 3, 4. We can press on our hash browns. If we press on 1, you get our little pop-up box that says whatever, because it wasn't very creative. And you can close out of that. But you can see how you could take this as the basis for building and building and building and building and building and building and building. And again, that's why modular design is good and object-oriented programming is good, to say, just build this chunk, build this chunk. Have in mind the fact that whatever you create, it's not going to be the end state. It is going to go through several iterations. And you all have hopefully seen this with the Finch assignments that you've had, where, okay, you did that, okay, now build upon that, now build upon that, now build upon that, now build upon that. And that's what you do. Okay, it is very much, it's Legos. Where this, and then you can also take it apart and build new things based off of if you structured your pieces well, you can reuse them to create entirely new constructions.